Today, I want to introduce you to one of my favorite features we offer at Blues, Notecard Outboard Firmware Update. With this feature, you can use your Notecard to update host microcontroller firmware from the outside, aka in a way that doesn't depend on firmware running on your host at all. In this video, I'll show you the steps you need to take to make Notecard Outboard Firmware Update work in your projects, and I'll be showing off those steps in action using the brand new Notecarrier CX. The CX is a note carrier that also has an onboard host microcontroller, the Blues Signet, and it's my favorite new thing, so you'll also get a bit of a demo for how the CX works as well. Let's get started. All right, I'm starting by opening up our documentation on Notecard Outboard Firmware Update, which I have a link to in this video's description. And what I like about this guide is that it breaks the process into 5 steps. And what we're going to do is follow along and go through each of these 5 steps in the video. Step 1 is to ensure your hardware is using the required wiring. If you're using a Notecarrier CX or a Notecarrier F for your project, this wiring is already in place, so you actually have no work to do here. If you don't though, your task is to make the following connections between your Notecard and your host. Notecard actually has 2 sets of pins that can be used for DFU. When available, we recommend using the Alt DFU pins, which are over here on the left side of this column, as they're pins that are dedicated for DFU, and they are available on most modern Notecard SKUs. However, the Alt DFU pins aren't broken out on some of our note carriers, like the Notecarrier A or Notecarrier X, for example. So if you're using one of those carriers, you'll need to use Notecard's aux pins instead. There's nothing wrong with using a Notecard's aux pins for DFU. The only downside is that there are other Notecard features that do leverage the aux pins, and you can't use a lot of those features if the aux pins are dedicated to performing firmware updates. For my demo, since I'm using the CX, I already have the Alt DFU wiring in place, so I'm ready to move on to step 2. And step 2 is to configure your Notecard to perform host firmware updates, which you can do with the card.dfu request. This step is necessary because Notecard needs to know about the architecture of the host it'll be updating. For example, whether you're using an STM32 or ESP32 board or whatever. And this is also the argument you use to tell your Notecard whether to use its aux pins or Alt DFU pins to perform the update itself. To show off what I'm using, I'll switch over to my firmware, which is just a really simple Arduino project. And as part of my setup over here, you'll see that I am calling card.dfu with a name of STM32 because Blues Signet is an STM32 based microcontroller. And I'm setting my mode to Alt DFU because the CX has all of the Notecard Alt DFU pins wired up for me. And if you look right below this, you'll see I actually have one additional DFU related request in here that's technically optional, but that we recommend using, called dfu.status. This request takes a bunch of metadata in the version argument and reports it up to NoteHub. If we go back to our documentation, and it's actually right up here, you'll see that we have a section in here that spells out the format that you can use for this version argument. So you can either spell it out this way, or we have some copy and paste friendly C code down here that you can bring into your firmware directly. For my demo, I've actually already copy and pasted this code over. So if I switch over to my config.h file over here, you'll see I have a bunch of metadata because this is a really simple weather app. And all this gets concatenated down into this firmware version function. And that function is what I use over here to provide that information to Notecard so that it can report it up to NoteHub. And if I switch over to NoteHub, just so you can see this, my backend for this weather app, I've got my one device on this project, which I'll open up. I will switch over to my firmware tab, and you can see the metadata that came from my firmware displays up here, which just gives you a convenient way of viewing the details of the firmware that your host is actually running. And that's the end of step 2, and that's actually all the setup that we need to do. Next, we need to actually update our firmware. So what I'm going to do is go into our code, and I'm going to make one quick check here, one quick update that is, and I think AI is going to help me make this really, really quickly. I'm just going to add support for humidity as part of my object. I think I need to add it in one more place over here. Oh, I like the full name. I'm going to call this humidity. And then I'm also going to go into my config, and I'm just going to bump up the major version of this to 2 to keep things pretty simple. And then I need to build, and how you build your binary depends on the platform or the RTOS you're using. Personally, I'm using Platform.io, so I can just use Platform.io's build command. And once that finishes, and that's a pretty quick build, I happen to know from past experience that Platform.io puts the binary in the projects.pio file. So it's going to be right over here. And what I'm going to do is I'm going to, if you give me a minute to manage my windows, I'm going to drop this binary on my desktop just to make it a little bit easier to work with. And what I could do is I could take this bin file and upload it to NoteHub directly. But if possible, we recommend running one additional step to process the binary before uploading it, called binpack. Binpack is a utility that's built into the Notecard CLI, which you can install on Windows, Mac OS, or Linux. And if I go back to the documentation and scroll down, you'll see we're now solidly into step 3, which is building it. So we went through and we did that. And then you see there's also this section on binpack that's going to show you how to use it with the Notecard CLI. And if you follow this link here for the Notecard CLI, it'll tell you how to install it on your machine and everything. And the actual thing you have to run is fairly straightforward. This line looks very intimidating. It looks like what you're going to have to do is really quite hard. But what I always do is I just copy and paste either this line if I'm working with an STM32 host, or this line if I'm using an ESP32 based host. And I'll just copy that. I will bring up my terminal. I'll paste this in, and then I just need to update the path to the binary here, which mine is just called firmware.bin, and run it. And it dropped it on my other desktop, so I'll bring it over here. But you'll see the main thing this did is it reduced the size of my binary by about 10%. I can break that out so we can see that firmware.bin, this binpack is a decent amount smaller. Well, 10% is smaller than the initial binary. And this is important because if you are using cellular, if you're using a Notecard Cellular, a Notecard Cell plus Wi-Fi that's set to cellular, this is a binary that's going to get transmitted over that cellular connection and use part of your data plan. So taking this additional step to optimize it so that you use less data is usually a good idea. Regardless though, once your binary is ready, packed or not, you can move on to step 4 to scroll down a little bit here and upload your firmware binary in NoteHub. So what I'll do is go over to the firmware tab in my NoteHub project and click this upload button. I will drag the binpack file over, and really that's all I have to do. I can save this. I'll just point out that you could also do this. We can just real quick head to the API documentation for NoteHub, because there's also an endpoint, really just basically anything you can do in the NoteHub user interface you can usually do with the API. And there's also an API for uploading firmware. So if you're looking to automate all of this as part of some CI process or something, there are endpoints for doing that as well. But once it's uploaded, if we go back to NoteHub and we go back over to our device, what I can do is go back to that firmware tab, and I can click update, and I can apply this to my device. And I'll go ahead and queue that up. Once again, there are also endpoints for doing this. So it's also, I think it's perform DFU. Yeah, perform DFU action. And this is an endpoint that's especially nice as you start to scale up your projects, because you can also perform firmware updates on multiple devices using a number of different filters. So you can provide an array of device UIDs, a tag, a fleet ID, those sorts of things as well. For our purposes today, though, I'm fine just scheduling this update through the user interface. And you'll see that it now displays as an update in progress and awaiting a connection. The reason for this is when you schedule a firmware update, under the hood, NoteHub is going to set a reserved environment variable to tell your Notecard about the requested host firmware version. What this means is that your Notecard won't actually detect the update until its next inbound sync when it retrieves these variables locally. One more quick note. By default, a Notecard is going to apply a host firmware update as soon as it gets that environment variable update. But if you want a little bit more control about when the updates are applied, there are 2 reserved environment variables you can set on your devices. The _DFU period variable allows you to ensure DFU actions only occur during specific time periods. So you could, for example, disable DFU actions on certain days of the week or certain times. And then the _DFU enabled variable lets you enable DFU actions based on Notecard voltage thresholds. For example, this value here in this example allows DFU actions when on USB or high or normal battery power, but disables them when the battery is low or is dead. Back to our example, I've queued up a firmware update, but I haven't gotten it yet because my Notecard's inbound interval is set to 60 minutes, meaning it might take up to an hour before I actually get that change. So because I don't want to wait, let's open up Notecard's in-browser terminal where I've already got a connection to my Notecard, and I'm going to run a hub.sync request to pull that inbound data down. I'm also going to enable trace mode on my Notecard, so card.trace mode on, which is a debugging feature of Notecard that tells it to do some extra logging. And you'll see, I'll probably fast forward this a little bit, but as part of this, it detected the update, and then it's starting to pull it down. It's finishing up the sync. And then when it's done with that, you'll see that it's now writing the flash over. After that, it'll do a bit of checking to make sure it applied the update correctly. So we'll fast forward to the end of this. And it just looked like it finished. I gotta grab my scroll bar over here. So it verified that it finished. It says the host firmware update's complete, and then it goes about its business. So what I should be able to do is come back into NoteHub, and you'll recall we added humidity to our project. So we've got our humidity coming through. And then if I go into my device, go into the firmware tab, I can see that I am now using version 2.0. Overall, Notecard Outboard Firmware Update is a powerful feature that just makes it seamless to update host firmware on ESP32 and STM32 based devices. It's a feature that honestly becomes a necessity as your project starts to scale, and you need the ability to manage host firmware remotely, to debug problems, or to recover brick devices. And if you use Blue's hardware like the Notecarrier F or CX, the process is even easier, as all the wiring is done for you as well. Try it out, and if you have any questions or feedback, let us know in our community forum at discuss.blues.com.